Hi, this is Peter from Chipkin Automation Systems. I'm going to show you how to capture some RS232 data. This is what you'll need. I use real-term. I used to use Hyperterminal, and I never became someone who came to love PuTTY, but I hear it's great, so feel free to use what you like. I need a USB to 232 converter, a laptop, and a cable to connect the data that is transmitting data. I like to carry around a bag of mini tester on RS232 breakout box, gender changes, 9 to 25 pin converters, D-type connector kits. You never know what you're going to need to actually connect things together, and you may need some wire for jumpers too. Our company sells a 485 232 to USB converter. I'm using it in the 232 mode. You can contact us if you want one. It's a great converter. There are lots of cheap no-frills devices like I'm showing on the left there. That one's RS232 only. Some of them need additional software when you install them. It's a bit of a pain, but that's the way it is. When you install one of these devices, you never know what COM port it's going to be assigned to, and that can be the one that'll hiccup. So you need to learn your COM port number. Use the device manager to find where the COM port, what port number to use. To find the device manager, just type device manager into your Windows bar. And there I'm showing that my USB device is on COM4, and I also just want to draw your attention to a little exclamation point. You don't want one of those next to your devices. It means it wasn't properly installed. Download and install real-term. Now it's time to connect to the device that's transmitting data. And let me tell you what I mean by the device transmitting data. We're listening to a 232 port. We're not generating data. We've got to get the data from the device. So if that device is a server device, a slave, you're not going to get anything out of it because it's waiting for you to send it a message before it responds. So for the purposes of this exercise, this movie, I am assuming that the device we're going to connect to is transmitting data to us, and then we're going to capture that data. In other words, it's a master if you're talking Modbus or something like that. I'm showing a 3-wire connection, and that's what the minimum you need for RS232, a transmit, a receive, and a ground line. And it's possible that you might need to switch your transmit and receive wires around to see the data. Not every device is labeled consistently. Sometimes you might need to put jumpers on the transmitting devices to get it to transmit. Look at our website, you'll find additional information there. Hopefully you can find this information in the manual of the device you're going to listen to. If you can't and you have to take some guesses, well, this software is really good at that. You can just change things and click change. You don't have to open and close the session all the time. So if you don't know, a good place to start is 9600-891, and almost always it's going to be none for hardware flow control. 99.99%. If you have to play with hardware control, you need to go find another movie to watch. So if the device is very, very old, 30 years, then you might want to try some low baud rates, 12, 24, 4800. Most devices default to 9600-891. 19200-891. It's not that common to see parity. If it is there, it's mostly even, and sometimes you see 7 data bits, 2 stop bits, and odd parity. Okay, we got the capture started, it's running, data is appearing in our window, and we are going to capture some of this data to file. So first let's just show you what it looks like when the thing is running. And we're going to capture the data to file. Careful to back up before you overwrite. Okay, before you leave site, please inspect the file and make sure there's some data there. Hate for you to have to go back and repeat the trip. And should the data look like? It's hard to say because there's so many different protocols. But chances are it's not going to be mostly human readable. You'll know you've got a decent capture if you can see some kind of a pattern in it. Why don't you, if you feel unsure, call in tech support and ask what a capture file should look like before you leave the site. I'm showing a breakout box here, but could just as easily have been a mini tester. The idea is that when there's some voltage on the pin, the LED is lit. So if you're not getting data and it's too hard to swap the TX and RX around, or you want to be sure which one's the transmitter and which one's the receiver, this is the process that you should follow. You connect the one device to the breakout box, and you see whether it's a TD or RD light that's lit. Then you remove that and you connect the other one and you make sure it's the opposite. If they both light the same one, then you're going to have a data collision.